So this is our Omnibot Restoration and Modernization project. The goal with our objective in completing this project was to clean up and then refurbish the Omnibot with modern hardware, because the original Omnibot was remote control and it was made in the 80s. Talk about like the cleanup process.
So the Omnibot used to be extremely yellow due to the aging of time and being in open air exposed to the sun. And we dipped it in hydrogen peroxide for about 5 hours and left it soaking in the sun's UV rays, and that restored a lot of it to normal white color. It used to be extremely yellow, but now it's more a softer yellow than it was before.
I was in charge mainly of some hardware design and some of the mounting for the Omnibot. In the bottom left there, we have the internal mount that is holding in all of our PCBs that we designed. It is currently sitting on top of the old tape player that currently is just there for looks and for structural purposes, but it holds our mounts and our Raspberry Pi along with our Arduino that we purchased to compute all the stuff. The Raspberry Pi is on there, and it's capable of doing all of the LLM and object detection, which we'll talk about. And the Arduino is purely there for controlling the motors, as well as using the sensors on the front to guide where it is going. And that takes us to the circuits, which this circuit, the one I designed, is the power control circuit. It takes in the 12-volt battery that we have in the back, and it gets all the proper voltages for everything that we need. So the 6 volts for the motors that is controlled, and then the 5 volts, which is powered by which powers the Raspberry Pi. And that goes to.
Okay, so I was in charge of doing the kind of audio side of stuff. So me and Caleb partially designed the speaker circuit and the microphone circuit, and we ran into some issues with the speaker circuit and caused it to, at least one of the chips burnt out, so we no longer use that. We're using a backup. We were using a Bluetooth speaker instead. And for the microphone circuit, we were having issues getting it to output as well, so we ended up going with the the microphone that's in the camera. And essentially the idea with those is to make it so you can talk to it, and it'll be able to hear what you're saying, understand it, and then talk back. And so the goal with this project mostly was just to be able to do entertainment purposes. It's not really for anything else other than just having a little robot to follow you around, parse the room, and talk to you, like look at you, stuff like that. And then, yeah.
So with the robot, it has ultrasonic sensors and a code inside of it that uses those sensors to detect an object in its path. If it detects an object in its left sensor, it'll turn to the right to try and avoid it. Same thing if it's in the right sensor, it'll turn left to try and avoid it. If the sensors detect the same object or close enough to the same object, it'll choose a random direction to turn in either left or right. We do have a slight problem where at a certain angle of an object and the Omnibot, if it's at an angle, the sensors will send a signal, but it won't bounce back to the Omnibot.
So I'll get in frame. So the Raspberry Pi in the Omnibot has a program with it in it which allows it to run a local large language model. There are a couple of libraries that make that possible, and I can sort of explain what each of them do. So there is one called Open Wake Word, which makes it so saying a key phrase makes it so the Omnibot actually starts listening. There is then a optimized version of OpenAI's Whisper named Faster Whisper, which translates the speech given, someone saying it, into text that the Raspberry Pi can understand. I then used Llama CPP to implement the large language model, and I am currently using a condensed version of Llama 3.2.1. I then use Piper TTS in order to translate that speech from the large language model back into speech, which outputs through the speaker. The Raspberry Pi also has software in it which allows it to have image recognition. It uses You Only Look Once. We have that, so it can recognize when people are in front of it. The purpose of this project is mainly for in entertainment purposes. The purpose of the Omnibot is entertainment purposes, but going through this project, we managed to turn the remote-controlled old Omnibot into an autonomous robot.